It's going to be important to be able to show on a test the dividing of fractions visually. And we're going to do this, the easiest way to show this is to show it as a ratio of comparison of 1/4 divided by 1/2 will be 1/4 compared to 1/2 as a ratio of comparison. Okay, so if I write my 1/4 fraction in the numerator, and I show my 1/2 fraction in the denominator, I can see that there is going to be a 1:2 comparison. So the answer must be 1/2. Okay, so we have to be able to show this as a picture. And you'll be asked to do this on a test as well. But if you're not being asked to do this as a picture, it's much easier to use our new rule. So instead of division, we're going to change it to multiplication. And since we're doing the exact opposite of what we're being asked to do, we need to compensate for that with an opposite of the reciprocal in the second fraction. So you're going to rewrite this as 1/4 times 3/2. And then we can just multiply top times top, bottom times bottom. So rewriting this as division, we can write, multiplication, we can write this as 3/4 times, we'll do the reciprocal. Okay, since we're doing the opposite, we have to compensate by doing another opposite. Here, times 4 divide 4 cancel out, and we end up with 3/5. Now, I'm going to show you something that you can do, but it's not something we should do. The rules for multiplication and division really are the same because multiplication and division behave in the same way. So if we can do top times top, bottom times bottom, we should be able to do top divided by top, bottom divided by bottom. And we can. If we do top divided by top, we get 3/5. Bottom divided by bottom is 4 divided by 4 is 1. Anything divided by 1 is equal to itself. So although we can do this, and it's important to understand the mathematical property behind this, is that times and divide are the same thing. They're just the opposites or inverses of each other, so they share the same rules. So if we have a rule for multiplication of fraction, that rule actually works for division of fractions as well. Now that's not something we should do, because what ends up often happening is we just end up with another fraction divided by fraction, which makes it just as hard as what we started with. So we want to use this opposite, divide changes to times, and compensate for that opposite by flipping that second fraction. Okay, so we have 1/3. We're going to change that divide to its opposite. We're going to compensate for that opposite by doing another opposite. We're going to end up with 6/15. Okay, there's a common factor of 3 which I could have simplified out, and I'm going to simplify out now. So I'm going to divide by 3 on both top and bottom to give me 2/5. So again, 3/8. Change the divide to its opposite. Compensate for that opposite with another opposite. The 3's cancel out. I have a times 4, divide by 4. So I end up with, if nothing's left over here, remember that when everything cancels with times, we're left with 1. And then we have 2 on the bottom. So here we end up with 2/3 opposite, opposite. The times 2 divide 2 undo each other, and we end up with 5/3. So again, we do the divide becomes its opposite. We compensate for that opposite with another opposite. I have a times 4 here and a divide 4 which cancels out. So I end up with 3 times 6, 5 times 1. So our answer becomes 6/5. So you can do the rest of these on your own. You can check your answer on the bottom. So the same thing is going to apply. Just remember the principle that we're using is that if we want to change that to a multiplication, we just have to compensate for it by doing an opposite of division and opposite of the fraction, which is the reciprocal. We flip the times into the bottom as divide, the divide on the bottom as times, and we've done an opposite by doing that.